Alright, this is the compound probability guided practice. The intent here is that you print out the worksheet, you try the first problem, and then you watch the solution. Then you pause the video, try the next problem, unpause the video, watch the solution, and continue on with this so that you get some practice where you know whether you got it right or wrong immediately. If you go through and do it that way, you're going to learn a lot and gain many skills. If you just watch the video, that will be helpful, but nowhere near as helpful as if you do the problems yourself first. Okay, a number cube is rolled and the spinner is spun. Find each probability. First, probability of 2 and a green triangle. Okay, probability of 2, there is 1 2 on the number cube out of the 6 numbers on the number cube. And the green triangle, it happens once out of the 8 sections on the spinner. This gives us a probability of 1 out of 48. Okay, number 2, an odd number and a circle. An odd number happens 3 out of 6 times, and a circle, there's a white circle, a blue circle. Looks like there are 2 circles out of the 8 positions, giving us 6 out of 48, or 1/8. All right, number 3. Picking a prime number and a quadrilateral. Okay, you need to know what the prime numbers are. Prime numbers, and you will need to know this on the test, because you'll have a probability of prime numbers. Prime numbers are numbers that cannot be factored. Numbers like 2, 3, 5, 7, 11, 13, 17, 19. These are the first several prime numbers. These are numbers that cannot be factored. Numbers that are not prime are called composite numbers, and these are numbers that can be factored. The first composite number is 4, then 6, 8, 9, 10, 12, 14, 15, 16, 18, etc. There is another type of number that I have not included here. It's called a unit, and there's only one of those. It's 1. So prime numbers cannot be factored. Composite numbers can be factored. So prime numbers. P, the probability of a prime number and a quadrilateral. Okay, when you roll a number cube, the prime numbers on it are 2, 3, and 5. That's 3 out of the 6 of them. And a quadrilateral, okay, quadrilaterals include a lot of things. A rectangle is a quadrilateral, so is a rhombus, so is a square, as is a trapezoid. There are 4 quadrilaterals here. This is 12 out of 48, which reduces to a probability of 1/4. Number 4, a number greater than 4 and a parallelogram. Okay, on the die, the numbers greater than 4 are just 5 and 6. There are 2 of them out of 6. A parallelogram, okay, parallelograms, a square is a type of parallelogram, and a rhombus is a type of parallelogram, so is a rectangle. A trapezoid is not a parallelogram. So there are 3 out of the 8. 2 times 3, this is 6 out of 48, which does reduce to 1/8. So the probability is 1/8. Number 5. There are 5 yellow marbles, 1 purple marble, 3 green marbles, and 3 red marbles in a bag. Once a marble is drawn, it is replaced. Find the probability of each outcome. A purple, then a red. Okay, purple marble, there's 1 purple marble out of, we're going to have to add that up. We've got 5 yellow, 1 purple, 3 green, and 3 red. Let's see, this is yellow 5, purple, green, and red. And total, that's 3, 6, 7, 12. So drawing a purple has a 1 in 12 chance. Drawing a red, let's see, the marble is replaced, so we still have 12 marbles when we draw the red, and 3 out of the 12 are red. This gives us, I'm going to go ahead and reduce first here. This gives us 1/48 being the probability. Number 6, a red and then a green. Red will happen 3 out of the 12 times. Green will happen 3 out of the 12 times. It's a good idea to go ahead and reduce these first. This is 1/4 times 1/4, which is 1/16. Probability of getting a red and then a green is 1/16. Okay, 2 green marbles in a row. Okay, first, for the first green marble, it's 3 out of 12. For the second green marble, after putting it back, it's still 3 out of 12. This is 1/4 times 1/4, which is 1/16. Okay, number 8. 2 red marbles in a row. Well, 3 out of 12 times 3 out of 12. I think I've seen this one before. Maybe this time I'll do it without reducing first. This would be 9 out of 144. And then you reduce that and it comes out to be 1/16. Okay, number 9. A purple and then a green marble. Okay, purple happens 1 out of 12. Green happens 3 out of 12. This is just the same as number 5. It is 3 out of 144, which reduces to 1 out of 48. Number 10. A red and then a yellow. Okay, red is 3 out of 12. Yellow is 5 out of 12. 3 out of 12 reduces to 1/4. This gives us a probability of 5 out of 48, 5/48 of getting a red and then a yellow. Okay, number 11. There are 4 yellow marbles, 3 purple marbles, 1 green marble, and 1 white marble in the bag. Once a marble is drawn, it is not replaced. Find the probability of each outcome. Okay, we have yellow, there are 4, purple, there are 3, green, 1, white, 1. That actually is a total of, looks like 9 marbles. Yeah, 9 marbles. Okay, purple marble drawn first. There are 3 purples out of the 9. And then we're going to draw a white marble. Now, once that purple marble's been drawn, there are only 8 marbles left. And of those, only one of them is white. So this is 3 out of 72, which is a probability of 1 out of 24. Number 12, a white and then a green marble. Okay, the white happens 1 out of 9. There are 9 marbles. We keep that marble, so there's only 8 marbles for the second draw. And it would be green. There's 1 green, so this is 1 out of 72. So there's a 1 in 72 probability of getting white and then green. Okay, 2 purple marbles in a row. For the first purple marble, there are 3 out of 9. After that's been picked, there's only 8 marbles left, and only 2 of them are purple because we already have a purple one. This gives us 6 out of 72, which is 1/12. Okay, 2 yellow marbles in a row. 2 yellow marbles in a row. Well, the first yellow marble has a 4 in 9 chance, and the second yellow marble, there's only 8 marbles left. Only 3 of them are yellow. This is 12 out of 72, or 1/6. Okay, number 15, a yellow and then a purple. The yellow marble happens 4 out of 9 times. The purple happens 3 times out of, there's only 8 marbles left. And I've seen this probability before. It was number 14. 12 out of 72, which reduces to 1/6. A green and then a white. The green marble happens 1 out of 9 times. The white marble happens 1 out of 9 times. This, or 1 out of 8 at this point. This one looks just the same as number 12, except on 12 we had a white and then a green. Now we have a green and then a white. Okay. 2 cards are drawn from a standard deck of phase 10 cards. A deck of phase 10 cards has 108 cards, as shown in the table. Find the probability of each outcome. 2 cards are drawn from a standard deck. Because 2 cards are drawn, we'll assume they're drawn at the same time. which means this is a dependent probability problem. We pick a card, and then the next card only has 107 cards to pick from instead of the 108 total. So, number 17, a red card and a skip. The red card has a probability of 26 out of 108, and the skip is 4 out of 107. Okay, 4 goes into 108 27 times. So on the top we get 26, and on the bottom 27 times 107 is 2889. Let's see if this reduces. It's done. Okay, number 18, a yellow card, that's 26 out of 108, and a green card, that's 26 out of 107. We can reduce here. This reduces to 54 with 13 on top. We can also reduce here, another multiple of 2. And we get 13 times 13 on top, which is 169. And on bottom, 27 times 107, which is 2889. And this does not reduce. So there's your probability, 169 out of 2889. Okay, 2 double-digit numbers. Double-digit numbers. Well, those would be 10, 11, or 12. 1, 2, 3, 4, 5, 6. And we have another 6 here. So there's 6 red, 6 blue, 6 yellow, and 6 green. That's 24 out of the 108 for the first draw. And for the second draw, there are only 23 of them left out of 107. All right, a little bit of reducing we can do here. Divide top and bottom by 4, and we get 6 27ths. I don't think there's anything else that's going to reduce for us here. So 6 times 23 is 138. 27 times 107 is 2889. So this, getting 2 double-digit numbers, has a probability of 138 out of 2889. Okay, getting a 7 and then a 9. A 7, there are 2, 4, 6, 8 7s out of 108 cards. And now there's only 107 cards, and of which 9 represents 8 of them. A little bit of reducing here. If I divide top and bottom by 4 here, I get 2 out of 27. All right, 2 times 8 is 16, and 27 times 107 is 2889. Number 21, 2 wild cards. Let's see, 2 wild cards. A wild card, there are 2 in each color, and that's 2, 4, 6, 8. That's 8 of them. So there are 8 out of the 108, and then 7 out of the 108. Okay, same reducing as we did before in the last problem. And then multiply across, we get 14 out of 2889 as our probability. Okay, number 22, a blue card and a not blue card. All right, a blue card, there are 26 of them out of the 108. And not blue cards, well, now there's only 25 blue cards left out of the 107 cards. This would be 82 cards that are not blue out of the 107. And actually we could add that up. 26 red, 26 yellow, 26 green, plus 4 black cards would come out to be 82. I guess the skip cards are black. Let's do a little reducing here. Okay, so on top we get 13 times 41, which is 533. And 27 times 107 is 2889. So the probability of getting a blue card and then a not blue card is 533 out of 2889. Thank you for watching.